We got a fair coin. It's being thrown 4 times. Our random variable x is the number of heads obtained, and they want a probability distribution. So keep in mind, all a probability distribution is the number of outcomes that could possibly happen, in this case 0, 1, 2, 3, or 4, and then each one of their probabilities. And keep in mind, I'm throwing a coin 4 times. And then what I'm interested in is the number of heads. Now, each throw has 2 possibilities, so that means I've got 16 possible outcomes that I have to figure out. Now, there's a couple different ways to do it. One is to go ahead and make a table and just go through all the variations. For example, for 0 heads, how many different ways could that happen? Well, there's only one way that can happen if I've got tails, 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 and tails. And each one of those tails has got a probability of a half, 1/2 coming up. 1/2 to the 4th power is 1/16. And so I got my first probability for 0 heads. So then we're going to figure out how many different ways it could happen with 1 head. And I'm going to give you the first one. And then I want you to pause it and then see if you can come up with the rest. So for 1 head, we could have 1 head and then 3 tails. Okay, now pause it. All right, hopefully you did that, and here's what I got for the rest of them, and see how that compares to what you've got. I've got 4 different variations, and that would give me 4/16, and so I put the probability, because keep in mind, each one of those is going to multiply together to get 1/16, and then when I add them together, I'll have my 4/16. So that's the probability of getting 1 head. So now again, I'm going to go for 2 heads, and what I'm going to do is I'm going to list the first variation that I can come up with, and then I want you to pause the video and then try to come up with the rest on your own. So the first one I've got is going to be, for 2 heads, would be heads, heads, and then tails, tails. Now pause it, and then see what you can come up with. All right, hopefully you did that, and now we've got heads, tails, heads, tails, heads, tails, tails, heads, tails, heads, heads, tails, 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 heads, heads, and then they can go back and forth, tails, heads, tails, heads. That's what I come up with, and there are 6 of them. So again, when I add those up, I'm going to get 6/16. Now let's try it again with 3 heads. So I'm going to try to find the different ways to do 3 heads. I'll give you the first one that I've come up with. It's going to be heads, 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 and then a tail. Now, how many other ways can you come up with where you could get 3 heads? Pause it, and then see what you come up with. All right, hopefully you did that, and so now we've got tails, heads, heads, tails. That's a good one. And then I can go jag them back and forth. So I can go heads, tails, heads, tails. And then I can do it some more. I think there's one more. Heads, heads, tails, heads. And that gives me 4 different ways that can happen. And again, if each one multiplies together to get 1/16, that's going to give me 4/16. And then my last one is going to be, how many different ways can I get 4 heads? Well, that's pretty easy. We could stop right here. There's only one way to do that. That's to get a head, and then a head, and then a head, and then a head. And the probability of that is going to be 1/16. All right, so that's the probability distribution table. Just a listing of all the things that could possibly happen that I'm interested in this case, just getting a head, and then the probabilities associated with it. Now, this isn't the only way you come up with the different outcomes. You could also use a probability tree. The problem is when you got 4 different things happening, the tree can get kind of cumbersome, and if you're not really careful, then the branches start getting on top of each other, and then when you go to read the outcomes, well, it gets a little messy and hard to do. I mean, you can see here as I get to my 4th go-round that they're starting getting cramped together. And you could do this, and I'm not saying it's a problem. The probabilities are all 1/2. That part's easy. But recognizing the outcomes, if you don't draw it and spread it out, sometimes can be a pain. So if you're going to use a probability tree, just give yourself some room depending on what it is you're talking about. But sometimes just laying them out on a table is easier. Now, the last thing I want to tell you is that when you're doing your probability distribution table, make sure that all the probabilities add up to 1. If they don't, well, then you've missed something, and you can go back and check it. All right, that's all I got. Thanks for watching.